Right, welcome back to MECH 1340. Alright, PLCs. We are going through Chapter 7 through the book here, Programming Timers. I'm going to kind of hustle through this one a little bit more than the others because a lot of this is going to be more Alan Bradley. So I'm going to touch on some things in this chapter from the book, but I'm also going to do a separate lecture where we're programming timers on our Siemens Step 7 or TIA portal software so that you can kind of see the difference between the tagging and how that goes. But the fundamental, the guts of timers we're going to talk about here in the chapter so that we understand what timing is and how we use different types of timers and what they all are, and what function we might want to use a certain type of timer in. Okay? So, mechanical timing relays, right? They're used to delay opening or closing. So we can, like preheating your oven. All right, so you turn on, your oven to a set degrees. So you want to preheat it to 450. All right, it's going to wait, and it might either be a time delay. It could also have a temperature delay in there as well. We want to count down New Year's Eve, right? We have a timer that kicks off, and we're going to count down until the ball drops, or a stoplight, right? We want to program it to be green for a certain amount of time, then turn amber, then turn red, okay? And different things, along those lines. We've all used timers before. Your clock's kind of your timer if you want to see, on your phone if how fast someone's going or things like that, or you want to time how long it takes to do something. Same kind of concepts, okay? So time intervals. Okay, so the first kind of timer we're going to talk about is called an on-delay timer. Okay, this one's pneumatic, so some of you guys, we've already worked with timers and things like that, potentially in the fluid power class when you got into pneumatics. Okay, so same kind of thing. I really want you to make sure that you understand the terminals, or not the terminals, the schematics and the symbols for all these as well. Okay, but what it comes really down to with timers is, it's going to change states at the end of the time delay. So something that's normally open after the time delay is going to close. Something that's normally closed after the time delay is going to open, based on the time delay. So these are the symbols for an on-delay timer. Okay, it's the same symbol. One's normally open, one's normally closed. We can kind of see the difference between the two being normally open and normally closed, but that's really what it is. So, just understanding the symbols is the first part, but we need to notice how it says NOTC, normally open timed closed contact, or NCTO, normally closed timed to open contact. Okay, so that's how we're gonna, take a look at those. So how this would work, right? We have the on-delay timer, so it's gonna sit in the normally closed position for whenever the timer kicks on, and then after a certain amount of time it will, normally open position. It's going to stay in that state until it reaches the time delay, and then it will close. If we have the normally closed time open, right, on delay, so it's going to stay normally closed, and then you're going to set the amount of time for it, and then it opens after that time. So it's a delay for it to turn on. Off delay works the exact opposite. Make sure that you know that the symbols are different for an off delay timer. Okay, the arrow is pointing down, but we still have normally open, normally closed. So what's going to happen is when we hit the off delay timer, if it's normally open, all right, after the delayed time, after something shuts off, it will close off after the specified amount of time, or it will open after the specified amount of time. So that's an off delay. So if we power something off, all right, the best example I can give you is, think of your car door. All right, at night when you close your car door, you open your car door, you get out and you close the front door, and the dome light still stays on inside the car door for a certain amount of time. Well, that's based on what? The door closes, and then the time delay starts counting down. So say it's like 10 seconds, and then after that, the dome light turns off. So that's like an off delay when you do something like that. So there's a good example of where you would use an off delay timer. Okay, so we also can refer to the on delay timer as a DOE, delay on energize. So we're not going to turn it on until it reaches a certain amount of time. So what's going to happen here is when we close switch 1, we're energizing the timer coil. Okay, and the timing period starts to count. That doesn't mean that the light turns on. Okay, so this is really understanding how an on-delay timer works. We close the switch, the timer starts counting. So for this example, 10 seconds. After 10 seconds, that time delay sensor closes, all right, and then the light turns on. So that's an on delay. The switch closes, the timer starts actually counting. Once the elapsed time is reached, all right, the light will turn on because the normally open timer actually closes, all right, and allows the light to turn on. Okay, so in this case, this is the exact opposite. This is a normally closed time delay. So what happens is we close the switch, okay, and then we have what? The light's on, okay? We close the switch, the light's already on, and then the timer starts counting down for 10 seconds. When the timer reaches 10 seconds, the contactor opens and the light turns off. So this is kind of like the, you could use this as well for your dome light car scenario, right? The door's open, it opens this, there's a switch that realizes that your door's open, okay? And then the timer starts counting down once you close your door, right? You close your door, the switch closes, all right? And then the dome light counts down, all right, for 10 seconds and then turns off. So you can do it that way with an on-delay timer as well. So same scenario here, okay? So off-delay timer here, switch closes, 10 seconds. After it closes, then it's gonna do its job, okay, and close. So in this case, the switch closes, okay, and the time delay contactor is on. But the time delay contactor is not going to start counting until the switch is opened back up. It has to be de-energized. So if we close switch 1, nothing's really changing here. Then when we open switch 1, all right, the off-delay timer actually starts counting then. So we've opened the switch. So then it starts counting 10, 9, 8, 7, 6, or 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? And then when it reaches its 10 seconds, then the time delay switch closes and the light turns on. So it's a little backwards here. The off-delay timer only works when the circuit is de-energized, so there's a delay in turning it on. It would still work with the car dome light example as well. You could use either or. But just understand that, with the on-delay timer, you close the switch, it starts counting. Okay, with the off-delay timer, it's going to start counting when you de-energize, so when you open the switch. So that's where they're kind of backwards from each other when you use the off-delay versus the on-delay. Okay, and you can see this is a different scenario here using the normally closed off-delay versus the normally open off-delay. Alright, so we're going to talk about timer instructions here. Okay, so they're just like relays. So if we have timer instructions here for us, the most common ones that we're going to use are the on delay, the off delay, and the retentive timer. So TON, TOF, RTO. Okay, and we're going to go through all those. So when we talk about timer instructions, there's a preset time. Okay, that's the time duration for the timing circuit. So if I say, all right, I'm gonna set this preset time is to 10 seconds. So it's either gonna turn on after 10 seconds or turn off after 10 seconds, right? That's the preset time. The accumulated time is the time that counts as it's elapsing. So that's the times it's counting. So with the off delay timer, I've opened the switch, all right, and it starts counting 1, 2, 3. That's the accumulated time. So as it's actually doing that count, okay? Then we just have different time-based intervals, whether we're talking milliseconds, seconds, microseconds, and those sort of things as we go through everything. Okay, so just so you know that's how that's going to be with the time. And we'll show you how to do that in the next lecture when I get to all the Siemens representations of this. Okay, this is Allen Bradley and how we set up the timer here. Okay, so we have our normally open, normally closed contactor. That's our switch. We have our different type of timer there, right? So our time on delay timer, right? And then we have our timer address. So for us, T0, T1, T2, that's how we use it in Siemens. Okay, then we have a timer preset value that we have to set. So that's, I'm going to set that to what, 10 seconds or 20 seconds, however I want, that timer to, start and stop at 10 seconds or 20 seconds sort of thing. All right, then you can watch it. So the accumulated time is what you want to see as it goes through. So when we monitor the system and you watch it, these are all things that you're going to be able to monitor when we're actually running your program and watching it work on the PLC or on the simulator and things like that. So you'll be able to monitor and you'll be able to see the time counting up or down. All right, the TB, right, that's the increments. All right, so 0.1, and we're going to be in seconds, not milliseconds or things like that. Okay, so we can be in seconds, milliseconds, microseconds when we do the timer. All right, and you'll just be able to set that. But like I said, when we're going to do the Siemens stuff, I have a separate lecture. We're going to go through and do that. All right, if we have a block format retentive, so I'm going to step back aside. This is a coil format. Why? Because we got a contactor and then we have a coil. So we're going to be able to do both. We have coil and then we have the block one. All right, so our control line, right, that's our switch that's going in. We need to be able to reset the timers as well. Okay, so in the coil, when it resets, all right, it'll reset when we, open that switch back up at the beginning, or the contactor back up at the beginning. Here we have a reset line, something that's able to reset the timer. And we still have an output line that's still going to a coil, but we set everything in the block format. That's really kind of the big difference between. Okay, so if we took it like an on delay instruction, when we want to delay, all right, before an instruction becomes true. So we want to wait. So we want to flip a switch, we want to wait for 30 seconds, and then something turns on. That's really all we're doing with an on delay timer. Okay, so this is the Allen Bradley stuff. So for us, Siemens, we're going to use like T1, T2, T0, those sort of things. Allen Bradley, same kind of concept. We can use, they're saying, file is T, T4, and then timer number 1 or 2 or 3 or 4. So just a little bit different formatting between the Allen Bradley and the Siemens that we're going to use. And we can look at it in the table and see what's going on as well. Okay, we can keep track of what the preset value is versus the accumulated value, and you can see all of that in the timer table. Okay, and like I said, I'm going to go through this relatively fast for the Allen Bradley stuff because we don't do much Allen Bradley, but this is more for your knowledge about timers. All right, so the timer number in this case is T4.0, all right, and the timer base, okay, it's going to either be in seconds or 0.01 seconds, right? So if we have, and then we can get to million, micro, and those sort of things. So that's how you're going to set that. The preset value is 15. So you're going to set all these. This is if we're using a block timer, okay? And then we have our enable as well. So as it goes through here, this is what it's going to look like, all right, when we do like a ladder logic in Allen Bradley. So we have an input A, so that's our switch. Then we have what? A delay. It's a preset, so it's going to be a 10-second delay. And we're going to use the enable here, all right? So when we do this, okay, it's going to be a 10-second delay. We flip the switch and the timer starts counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. When it gets to 10, that's when it enables. So output B will turn on, okay? And then output D will be off, and there'll be vice versa on that one. So they'll swap values. Okay, so you're going to start thinking about this when we start doing, your stoplight and things like that. We're going to cover that a little bit more at the end. We go over it in Allen Bradley, but you're going to do it in Siemens when we go through this. So if we notice, all right, we have the timer. The timer's 4.0. Notice that each one of the contactors here on the left-hand side on rungs 2, 3, and 4 are timer 4.0. They're all the same. Okay, they're just monitoring the different output pieces from that timer. So that's going to control our output B, our output C, and our output D. Okay, so I mean essentially it looks like a stoplight, right? Like green, red, yellow, and when they come on and when they don't. Okay, so that's really. So what's that going to mean? That means the timer's counting up, and then the timer's reached its value, and then we kind of reset. Okay, so this is what it's looking like as you go through the timer in the Allen Bradley PLC logic, and you can see what's going on with the table as well. Okay, this particular example has set for 100. Okay, so context instantaneous. So we can use the output of the timer or the timer itself to be an input to a specific circuit as well. So if we want to do that, all right, in this place, all right, this is using an internal relay here to control the timer. So for us in Siemens terminology, that would be using a memory coil. So what is this? This is what? This is a stop start. So hitting the start button locks in this memory coil. And we use this memory coil to set the timer so that the motor won't start, okay, until the button's been on for 5 seconds. Okay? So we flip the switch and then it starts counting 1, 2, 3, 4, 5, and then the motor turns on from the output of the timer. Okay, so just a delayed start type scenario. See, so if we want to, just taking a look at these, and like I said, this is Alan Bradley stuff. Okay, so what do we got going on here? So we want the horn sounds for 10 seconds whenever the start button is actuated. So in this case, look, it's a time on delay, so it's a TON. So it's gonna preset for 10 seconds. So notice the horn and what it's tied to. Okay, and when it actually is going to go off. Okay, when we do this, we have what? Push button 1 and push button 2. And when we do the enable, okay, that's gonna go around push button 1. Does everybody see that? So when we hit push button 1, okay, we're using the enable and the do not enable down below, because we always have the outputs. What we have the true and the false coming out of the timer there. Okay, so we have not the false, and then as soon as enable goes on, okay, and turns on, after 10 seconds we'll run the horn and then it'll stop. Okay, why will it stop? Because the DN at the bottom will open back up. Okay, see how it's normally closed and it's live? All right, that'll open, okay, and that's what'll turn the horn off. Okay, and then we'll be bypassing push button 1, so it works automatically. And we'll do some labs in class that work through this as well. Okay, so just using it, we're going to use it to do some motor control, things like that, sequential motor control, and like I said, you're going to get the hang of this once we start going through the labs. Same kind of concept goes. We're off delay timer instructions here. Just the setup is the exact same as the on delay, only we're using an off delay. So I'm not going to spend a lot of time. You guys will have access to the slides, or you can pause the video and take a kind of a look at and see what goes on and how we control some things. But remember, just off delay timer means that it's not going to start until we de-energize the switch. Okay, so if the switch opens, the switch 1 opens, I1.0 opens here, or I1/0, sorry, I'm speaking Siemens. But when that switch opens, that's when this timer actually starts accumulating time. So very important to understand that. It's really understanding the difference between the off delay and the on delay timer. And once you understand that, it's just simple wiring and connecting them up to make them work. Okay, so we can, why would we want to use something like this? Say we want to switch motors off in intervals. So you have a whole fan system or something that you want to turn off. And you want to turn off one at a time. Well, look at how you do this. Okay, so we can cascade these. All right, so if we notice, the first motor is going to shut off what? After 5 seconds. The second one's going to shut off after 10 seconds. And the third one's going to shut off after 15 seconds. Okay, so look at the tag, for the timers. Notice there's 3 different timers here. There's timer 4.1, timer 4.2, and timer 4.3. So we're using what? If for it to shut off, it's not going to shut off until it's not DN. Okay, so that'll close the DN tag on each one, and it'll shut the motor off. Okay, so that's how we would write that in order to shut the motors off. So make sure that we're paying attention if we use normally open, normally closed contactors. And you guys, you're going to play with this in labs, and it's going to come to you, and it's going to make a lot more sense, like I said, once you guys get on the PLC and you're actually programming these, versus just trying to understand it through the lecture piece. Okay, the labs are very good as we do this. Okay, so let's talk about, just an example here. We got a fluid pumping process here. Okay, so we're pumping fluid from tank A to tank B. So before starting, our pressure switch must be closed. So we're taking this scenario here and we're going to write some ladder logic. When the start button is pushed, the pump starts. And then pressure switch 2 and pressure switch 3 must be closed 5 seconds after the pump starts. If either the pressure switch 2 or pressure switch 3 opens, the pump will shut off and will not be able to start again for another 14 seconds. Okay, so lots of different things going on here as we do this. So you might be able to pause this and write the scenario down and then kind of look at the next slide here as we got this going on. Alright, so we got our first command line that's running, the pump in general. But look, see, we can have the timers down below, and then we have the timer also in the first line, and that's completely fine. Alright, so if we want to start it, so the second we hit the start button, as long as it's not 4.5, then we're good, and pressure switch 1 has been closed. Everything should be good and start running. Then once the pump starts running, okay, we run our pump delay timer. So it's going to do what? After 5 seconds, okay, then it's going to turn on. So that's timer 4.6. So that goes down to the third rung there. Once 4.6 closes, then what? As long as we have pressure switch 1 and pressure switch 3, as long as those are closed, everything's going to work. If it doesn't, all right, we have that preset timer that's not going to allow things to work again until 14 more seconds. So go back, write down the scenario on the previous page and then look at this diagram. And that'll really kind of help you understand, what's going on and how to use the timer. Okay? So, retentive timer. Okay? Retentive means that it's going to retain information if it gets de-energized. Okay, so that's really what's happening. So if we start timing something and we remove power from the timer and then start picking that timer back up again, it will remember where it was in the time accumulation process. Now, why would we want that? Well, let's think about if we're filling a tank. Okay, and something happens and the power goes off and the tank is half full. Alright, and we're set to fill that tank not based on levels, but based on a certain amount of time. We know that if we're pumping into that tank for a certain amount of time, it will fill to this specific amount of level. Alright, so we want to know, alright, well, if the tank's already half full and the timer's been running, halfway, if the power goes out, we don't want the timer to start over and fill the tank, because then the tank's going to overflow. It's got to keep track of where it was. Why do we do it that way? Well, so if something does happen, we don't have to drain the entire tank and start over either. So that's really what's going on when we want to use a retentive timer. It accumulates the time, alright, and keeps track of the accumulated time and stores it. Alright, so if something gets removed. So you're going to see when we do the retentive timer, I'm going to toggle the switch on and off and on and off a bunch of times, and you'll see it'll still keep track of how much it's into its time before it goes forward. Okay, then you can still have retentive on delay and off delay for retentive timer. We're just storing its accumulation data. Now, when we start using retentive timer, it's important that you have a reset instruction. This timer will not reset on its own. You have to have something that resets the timer, or the timer will just do what you tell it to, and then it'll stop. So it's very important, don't forget this in class when you're running your programs, especially if you're using like a retentive timer to do your stoplight or something like that. You want to make sure that you have something that resets the timer. If you don't, alright, it's just a reset coil, you won't be able to. So look here, there's push button 2 in this ladder program that resets the timer. So you just need to understand whether we're going to reset the timer or not. It's separate from the actual timer function that you set. So there's a reset coil, and then there's the retentive on delay timer, the RTO, that we're looking at here. Okay, so that's really what's going on. This is just talking about bits and when it enables and when it's not. We've done a lot of that stuff in digital electronics, but like I said, I really want you guys to understand and do the programming. But here's just more of a exposing you to what the different types of timers are. We can go through a bunch of different scenarios here, but when you guys actually start doing them and programming in class, like I said, it's going to make a lot more sense. All right, and then if we start cascading timers, well, what's it mean to cascade a timer? It means when we start putting more than 2 timers together. So when you write your stoplight program, we're going to cascade timers, okay? So that you're going to have more than 2 timers cascaded together when we go through this, okay? Or if we want to, start them in a delayed sequence. We don't have a big unrush of current. All right, if we have a bunch of motors that we want to start in a delayed sequence, we can start them up. So, bring it back. We've got a bunch of cooling fans or something that need to turn on. We don't necessarily want to bring them all online at one time, right? There's a big inrush current. We can bring up one and have, different types of delays in between those. All right, and we call that sequential motor starting. And it's really, based on you and how you write your program for your timer, and how you set that up so that we can start motors, with different time variances between all of them. Okay, so we can use a flasher alarm for a timer and have it pulse on and pulse off, and we're going to get into that a little bit more, like I said, with the Siemens when we use pulse timers, okay, and retentive pulse timers as well. And like I said, that's going to be in the next lecture. Okay, but so we can use cascading of timers for longer time delays. So for you might want to use something like this. We can cascade timers. And it doesn't matter what kind of timer you're using, right? On delay timers, retentive timers, off delay timers. You can use a combination of all of them. It's not a specific type of timer you're using. It's how you're using the timers, if that makes sense. So you're going to do that when we do the stoplight program in class. So this is the Allen Bradley piece. Okay, it's going to be slightly different for us because I'm going to put in the other direction as well. All right, so you're going to have like one of your programs is going to control north-south, the other one's going to control east-west. So we have to do some other things like understanding, all right, I can only be red when I'm not green and not amber, all right, and certain things like this. But this will really help you kind of put the delays and take a perspective as we take a look at this program here. Yeah. Look at it, all right? So right now we have what? We have a timer for red, a timer for green, and a timer for amber. So how long is it going to be red? Well, it's going to be red for 30 seconds, right? Why? Well, because, it's got to be red and we want to sit there. Then we want to be able to green. And obviously amber, right, doesn't need to be on as long because it's a warning that it's going to turn red. So if you take a look, we have timer 4.0 is red, timer 4.1 is green, and timer 4.2 is amber. But notice how we're running things. So notice that it's not timer 4.2. So as long as it's not amber, we can start the red timer. Look at the green. As long as it's what? Red, we can start the green timer, okay, and then we can start the yellow timer and so on and so forth. So notice that for it to be red, okay, we have to have red closed and not red for it to go through, okay? And we'll get into the scenario when we start looking at class, because this is, once again, this is Allen Bradley driving lights versus we're going to do it a little bit different with our Siemens stuff. I want you to think about, the whole aspect of it. For it to be red, it has to be not amber and not green. Okay, so that's why they're going to be tied to different timers that are controlling red, green, and amber, and that sort of thing. Okay, so if we have the delay system here, so if we're just controlling one side, this is what it might look like if we were using some Allen Bradley. Okay, but I'm going to have you guys play with this in class, so I'm not going to talk about it a whole lot. I really want you guys to figure out the stoplight. I think once you get one light working, one direction going, red, green, amber, and so on and so forth, I think the other side's very easy. But the other important and the hardest part for you is to figure out how to make it loop. So I want you just to think about these things, and look through the Allen Bradley one and see how it's going to relate to our Siemens traffic light. And when I say Siemens traffic light, I mean, programming on our Siemens PLCs and things like that. All right, guys, hopefully you have a little bit better understanding about different types of timers, right? On delay timers, off delay timers, retentive on and off delay timers, okay? and being able to cascade timers, understanding what retentive is. We'll talk about pulse timers in a different lecture as well, and that's going to be more specific with our Siemens timers and things like that. Else, guys, email me if you have any questions. Let me know if you need to Zoom or team meet. Else, have a great day, and I will see you in class.